science and technology paradigms. Science and technology have changed the life as we know it, and everybody knows that. People 100 years ago, no, maybe 10 years ago, were not doing things we can do today because of science and technology. And even books are changing, even games are changing, even classroom is changing. And you can look around you and see how science and technology indeed revolutionize many paradigms in how we wake up in the morning and how we go to sleep, how we transport ourselves and our goods and travel, and you name it. This is the first EIU, Eastern Illinois University in Charleston, Illinois, first Science and Technology Symposium. And Dr. Stephen Daniels and myself, Dr. Stephen Daniels, the chair of the physics department, wish that this wouldn't be the last, but first in series that continue as science and technology continue to develop. Today I have the privilege of introducing my friend and colleague, Dr. Boonsuk. He is an assistant professor of applied engineering and technology at Eastern Illinois University in the School of Technology, where I also work. And I wouldn't take much time in introducing him. I leave this for him because he knows that better than I. And it's in the program, if you like. He will talk about rapid prototyping. Now, everything is rapid now. So without much ado, here is Dr. Boonsuk.
Right, thank you, Dr. Wabai. So today I want to talk about rapid prototyping. Basically, we're going to go over some basic concept and the idea behind the importance of this technology, why is it important, why do we need it, and also the application for this technology that we can see in the market right now. Okay. So let's start from what is rapid prototyping. Sometimes I call RP, many people also call RP in this case. So I have two definitions here. Basically, it involves with the machine, okay, that can automatically create the physical prototype, okay, from the 3D dimensional models, or sometimes we call CAD model, and it can create it in very short period of time. Okay. So we have learned a little bit about RP from this definition, but I'm gonna really go into some more detail why this technology is important, why we need to know about it. Okay. So before we start talking about RP or rapid prototyping, let's go back a little bit, learn about why it's important to have prototype. Okay, why we need prototype? Most of the time, prototype involved in product development. Okay. It's kind of the main step in product development that you have to have. You can start from planning, designing, develop prototype, and then make a test and present, help get some iteration until you get the final product's outcome. Okay. Prototypes serve, in this case, several things that it's important to have prototype because first thing, you can validate your design. Okay. You can take a look at your prototype and look at what can be a problem of your prototype. Sometimes you cannot really spot it if you look at it on the paper or in your computers. So, and also prototype is a proof of concept, right? And most of the time, people use it to attract the funding. Without a prototype, it is sometimes it's hard to really tell your sponsor to support it. Okay, so I kind of see this trend going on the internet. I'm not sure if many people in here have seen it. Some small company, they try to put their idea on the website and also make some prototype and then show how it works on the website and try to raise the money using that website. So people who interested in what they have or in their idea, you make something like a pre-purchase, okay? So the company get more funding and be able to push the products to the real production. So I really see it become more and more this way. So I think that's how prototype is very important. So why does it need to be rapid? When you be able to have prototype fast enough, so you'll be able to reduce the cycle when you try to develop the products. And if you reduce the time, it's absolutely help you to reduce the cost, okay, in the production. And also, you can bring your products to the markets faster, cheaper, and also have a higher qualities. Because we talked about before in previous slides that you can validate your design, you can look at the problems. So you can spot the problem before you have the final finished product. Okay? So prototype will help you do that, and you will be able to improve your quality of the products. Okay? So, anyway, it's kind of interesting that when we talk about rapid prototype, we think about it, we can create prototype in a short period of time. It doesn't mean that this process is very fast. It's absolutely not fast. Okay, rapid prototyping, the RP process itself, it can take about 1 hour, 2 hours. It can be 1 day, 2 days, or even a week to create just one part. Okay. If you compare it to manufacturing process, if you compare comparable something like injection molding, the process for injection molding, you can make the finished part. It probably take about like couple seconds, 5 seconds, 10 seconds to get the real products out. So it's not really fast, but why they call it rapid? Because the waiting time and the process time are equal. So basically, if you have the 3D model, you send it to the machine, you just wait it until you finish, you get the prototype. Okay. For manufacturing process, the problem is that you cannot order just one part or 2 parts. Okay. If you go to a manufacturer, you ask them, can you make me 2 parts of this? They're going to say, okay, if you order 2 parts, you can order 100 parts, it will be the same cost. Okay. And the waiting times, it can go up until a couple weeks or even a month. The problem is in manufacturing process, they need process planning. Okay, to create the part, they need to develop. If you talk about injection molding, they need to make the mold and make the design of the mold and acquire the materials and then create the parts. So that time adds up to make this process longer. Okay, even though the real process is very short, but RP process serve it well. If you want to create just 1 or 2 parts, you just sit and wait. Okay. So this is why this technology become more popular in manufacturing field. Okay. So in RP process, what do I need to make the prototype? Beside the RP machine, the computers, what you really need is just the CAD model, computer-aided design model. I know if many people in here are familiar with this term, but basically it's a computer model that you can design on the computer. So how to get that model? There are a couple ways. The first one is you use the CAD software. Very famous one, something like SolidWorks, okay, Solid Edge, Pro Engineering. This is when you create a design. You design your own part, your physical part, okay? And on the other hand, if you have some part that is already made and you don't have the real CAD model, you can recreate it using some process called reverse engineering. So basically you use the 3D scanner, laser scanner, so you will be able to get the model, the physical model, change it into the CAD model. Okay, so that's how it works. What is the idea behind RP? So you know that most of the time when we talk about RP technology, people will think about layer manufacturing, additive manufacturing, layer by layer process. So what does it look like actually? If you have, let's say we have the apple, okay, it's nice and crispy, red, delicious, and okay, assume that this is your 3D model that you have, okay, and then what if we slide it, okay, make it into the very thin slice. What happens is you simplify the 3D geometry, okay, to make just the 2D cross section. Okay, if you take just one slide here, put it here, it will look like this. So just 2D cross section or 2D slice of the apple. And then what if we stack it up, okay, according to how you slice this layer. Okay. You can see that you can really recreate the apple using something like this. And it's really simple and easy to do. Okay. So this is the concept behind RP machine. Okay. If you look inside the RP machine, you're really going to see something like this. This is one of the machines called stereolithography printer. Okay. So inside, there's some kind of liquid tank of the, there's a liquid polymer inside here. Okay. And they have some kind of platform that dip into this liquid. And we have laser on the top of the machine. So the laser will solidify the liquid polymer. Okay. For example, it starts from the first layer, and then after it finishes the first layer, the platform will drop down one layer, and then the laser will create the second layer, and then again it will drop down more and more until it finishes the part. So that's the idea behind layer by layer process. Okay, so RP system has expanded a lot. Okay. We've seen since 1980 that they start to develop the first machine, and right now there are lots of, so many of it in the market. If you have search in Google, rapid prototyping machine, you will see maybe hundreds of them, okay, from different companies. If we classify them, you can make classification based on the material that they use. So there are liquid-based, solid-based, and powder-based. So all of them use the same technique, create the part layer by layer. Okay. If we talk about solid base, you will have to melt the material and create it layer by layer. Also powder base, you have to fuse the powder, make it solid as a solid. Also, all use the same idea that I've already described. Okay. So let's talk about the applications of the RP. This is besides using for the product development, there are a couple of companies that use on some application that's quite interesting, and I want to share with you. First, start from the car companies. This one's still used for product development, but it's kind of interesting how they use it. So they use RP technology to create the console of the car. Okay, this is for a Chevrolet Malibu 2014, so I'm not sure it's already out or still in the production. But they create the console, and then they put the console inside the real car and have some person to come in to do like a pre-test to see how it works, if it's going to work well with the car. So what they try to add is that they add 2 slots here, which is the slot that used for the cell phone. Because, you know, people right now have cell phone. I think almost everyone got at least one cell phone. Okay? So there are 2 slots here that they add to the console, and they think it's probably a good idea to have it. So they have customer or other people come in to test it, if it's gonna work, the position, is it work well, something like that. So do some kind of iteration about this product and see how it works. And this show here is the final console in the real car that they create after this is verified by the people in the company. Okay. So interesting application. The other one is I want to show about the consumer products. So the shoe companies, I think one of them is Adidas, also use it. Nike also use it. They use the 3D printing to create the prototype. Okay. And the company claimed that within 6 months, they can do iteration for their prototype about 12 times. So that's a lot of improvement that they have in the past. Probably they just have like 1 month per one iteration. So this is so much improvement. So the products can develop even faster than normal. And what's shown here is the first shoe that produced using the rapid prototyping technology. So they print out the bottom part of the shoe, and this shoe is for NFL football player. So it's really for a specific group. Like what we know that the RP process takes quite a long time to create one piece of the products or prototype, right? But this is well because not many people are going to use this kind of shoe. So this is for a specific group, and I think it's very suitable to use this technology. Okay. The other application, if you look at some medical industry, okay, RP also have grown in there. The company used EDM machine or electron beam melting to develop the custom implant for the patient. So the implant made from some kind of titanium and other compound to put inside the patient. The good thing of this material is that it allows the soft tissue to grow around it. Okay, and this is really important because if you come in this field, you know that some of the implants, the patient body will reject the implant because it's not very suitable for them. So in this case, they'll be able to develop the material that really help to reduce the risk of rejection from the patient. And also the most important thing, they can create really custom fit to the patient. So they, instead of going to manufacturer, have them produce like 100 pieces to give it to just one patient, you can just print it out using this RP technology. So really customized to one customer. So very interesting, and I think it's really fit well for RP technology in this type of application.
What was the other picture?
This one, I think it's, if I'm not mistaken, it's probably a kneecap.
Okay.
Okay, just to take a look at how it grows in the market. So according to the Wohler reports, okay, the market share of 3D printing for the products and service is about 2.2 billion. Okay, this is worldwide in 2012. And a compound material that used inside the machine is growth by 30% from 2012 to from 2011 to 2012, and which is in 2012 is 1.7 billion, and it's really grown a lot if you see from here. And by 2017, this is the prediction that I think these 3D printing products and service will even grow bigger. It's going to reach about 6 billion worldwide. So you see that this technology is very growing. So what would be the future of this RP technology? This is, in my opinion, that I think it's going to really grow in custom-made products. So because it can produce only one or two parts, and it's really low cost if you compare how you're going to produce it, and it's easy to make. So something like I showed here, like a hearing aid. Okay, most of the time that if you have used like a standard hearing aid, it's kind of not fit really well and drop for the patient. So if you use RP technology, you can really customize, you can scan the ear and try to decide that, make the design that really fit well to the patient. So I think it's really going to grow in this area. As well as you can see, the trend now is really getting lower, the price of the machine and the material. Okay. 5 or 10 years ago, RP machine cost about 10,000 or 20,000 bucks. It's a very expensive machine to invest. But now you can see that there are several companies launch something more smaller and make it easier for consumer products. So they have, this is the MakerBot, which is start just 2,200 bucks. So the 3D cubes, cube 3D printers. So that's from 3D system. It starts just 1,300 bucks. So it's getting cheaper and cheaper. So I imagine in the future, not only you're going to have the printer to print on the paper, but you're going to have this kind of printer to print your 3D products, your hobby or whatever. So, right. So that will be all my presentation, and hopefully everyone have learned something about RP today.
Thank you very much.
Any question?
Yes, I have one to start with. There is some applications that came into the news lately about creating living body parts, like a liver, like a kidney or something, using the same technology or different?
I have heard about that. There's a company in Germany. They make the have this technology use 3D printer, but they can print the soft tissue. Okay. So I'm not quite sure like how far that they go, but it's kind of new, and it's really need to investigate, I think, more in order to really make it work.
What's amazing is how do they use non-living material to create a living member? I mean, it's kind of
Right.
very good. Any other questions? So please join me in thanking our speaker today. And